Okay, thank you. Hello, and welcome to my talk about Launchpad version 4 to infinity and beyond. So let's start with the basics. What's Launchpad? Launchpad is an MIT licensed library that provides building blocks for Smalltalk applications. Traditionally, we deploy Smalltalk applications as package images executed by the VM, and each deployment usually has some script used to decide which code to run when the VM executes the image, or some way to configure the package image, this initial launch code, like Mariano showed yesterday. So there's a couple of needs that every Smalltalk application needs. One is every Smalltalk application needs somehow to coordinate this startup. And when you have a graphical user interface, maybe it's obvious that you only have to do is to open the interface. But when you are running server code that you don't have a user interface, there are some things that you need to do as a startup. And probably many server applications want to do the same things. The second need to consider is the configuration. Mostly any application will need some kind of external configuration, not embedded in the image. Credentials, port, hostname, secrets. Somehow this information has to enter into the image. And finally, another aspect that usually is neglected is the application shutdown. Many applications will need to do some things before the shutdown, like closing connections or unregistering for service discovery registries. Before we implemented that, as an anecdote, we have some services that are registered in a centralized service discovery service. And we forgot to do the unregistration. So when the VM is closed, the registry thinks that it still has a service running. And everything we try to route that way wouldn't work. So it became more important for us because we started to have many services, and we started to see a pattern of the things that we need during a startup for configuring or for shut down these applications. So Launchpad reason d'etre is to cover these needs. Applications built on top of Launchpad are structured to standardize startup, configuration, and shutdown. These are the building blocks that Launchpad provides for this. So provides a command line interface that allows us to list, start, and explain what applications I have in an image, because sometimes it's pragmatic to have more than one application in the same package image. In an ideal world, you would think that I would only have one application per image, but sometimes we need to be pragmatic. So we have the option to have more than one application, and we need to start one of another or another. It also provides structured definition for configuration, for defining the configuration, or for later provisioning that configuration, because the application wouldn't work without the configuration, and we need later to provide that. It also provides affordances for logging and tracing. I will enter into more detail later. As a side effect of defining the configuration, the applications have inline support for help. So we can see all the parameters that we need for the application to run. And additionally, we added support for running containers. So we have the option to use base Launchpad Docker image to create our own image packaging our application. Okay, let's start with the basic part. This is the command line interface. I will. It's okay. Okay, the first, the entry point to the command line interface is the Launchpad command. I hope it's. Sorry, I mistyped. Okay, so the main entry point just lists the available commands. We have 3 options, and we can also see the version of Launchpad that we have installed. Okay, in that case, we have this specific version that was made from this Git commit. This is useful because sometimes you bump the version and forget to build the image, the Docker container image again. So it's handy to know the exact version that is installed. For the 3 subcommands we have, the first one is list, that essentially lists the applications available in the package image. So we can see an example. We can run Launchpad list. Okay. In this case, this package image has 2 applications: create MTR DBMS and currency API. We can also use the verbose flag. This shows the same information, but shows us the version of each application. And finally, we have every subcommand has its own help. Okay. In that case, we already saw the options, but the other commands have another options. Okay. The next one is explain. As its name implies, explains gives us detailed information about an application. So I will say Launchpad explain. I will use some of the applications contained. Okay, so here we are seeing application name, its version, a brief description, and all the configuration parameters that can be passed to this application. And for each one, how to pass it as command line parameters or environment variables. If you go. So if we don't remember how to configure something, we can use explain and obtain information. And this last one is obviously the one that we want to use, that is start. We quit here. Yeah, it's not a typo. No. Okay, now the application is running. We can do something like, I don't know. I hope I have typed right. Okay, now we use curl to send a request, and we have a response. Okay, the application is now running. So this is the command line interface. We have 3 options to use. Another building block that provides is the configuration parameters. Every application needs to declare somehow what configuration they need. Configuration parameters came in 2 flavors: mandatory and optional, and 1 modifier. Mandatory parameters are required. The application will refuse to start if we miss some value for these parameters. And optional parameters will use some default value. And the sensitive parameter, it's a modifier on any of the other 2. And at this moment, basically hides its value on the login. So it wouldn't leak secrets. And in the future, one idea that we have is to encrypt probably this value in memory and not have it available all the time. Also, both mandatory and optional parameters can be marked as sensitive. For applications with a lot of external configuration, we need to organize this somehow. So for this purpose, configuration parameters are groupable into sections. You can group into sections parameters. So let's see how a definition of a parameter will look. Here we have one mandatory parameter and one optional configuration parameter. They have a name, the description that is used in the help, and you can nest it in a section, in one or more sections, and the optional one has the default value. This is the first aspect that we need to define, to declare the configuration parameters that we need. But later, when the application starts, we need to provision that values. Every parameter needs a specific value to run. For that, we have three options to configure that parameters. It can be done by command line arguments, by using environment variables, or using setting files, right now in JSON or any format. So here I will open, for example, a Pharo image. Oh, it got open here. So here we have an inspector over a running application, so we can see the same help that you can get in the command line. We can see the parameter list, the required parameter list, and if we inspect the configuration of the running application, we can see every value and how to pass these parameters if we want to use the JSON format or any format or command line interface or environment variables. This is useful because when you have a large configuration, it's usually easier to do it in the image and later take a look at how the configuration files must look. Okay, I will close that. So here are, for these parameters, an interesting aspect is that given the name that we give to the parameter, it's the way that it gets encoded on the different formats. For command line parameters and environment variables, the sections are encoded in the same name because there is no other way. For ini files, there is section support in ini files, but it's only one level. So if we have nested sections, we merge it in one section per combination of any nesting level. And in JSON, you can have any nesting level for sections that you need. Okay. Another building block is the login infrastructure. When you don't have a graphic user interface, and the application crashes or something bad happens, you will need login. So Launchpad provides login. It's used in Beacon. It's a framework that is available in Pharo that has the nice property that it separates the responsibility of who emits the signals, the login signals, and how these signals are later or written to file or sent to some service. So you have the loggers and the signals. Launchpad provides the signals for the standard levels, trace, debug, info, and warning and error. And there is an option to, by default, the errors and warnings are sent to standard error, and the others are sent to standard output, but it can be configured for the user that makes the application. And another interesting aspect is that when you output this information, you can output them in JSON format structure, and you can also add, besides the message that in the standard login you have a timestamp and the login level and the message, you can put like standard data, standardized data. So you can say, okay, I want this field with this value, this field with this value, and this is written. And if you're using some kind of platform that consolidates logs, later you can query for that information. So here, I will come back. Okay. I didn't mention that, but we are running the image in Docker. Okay, this guy is related. I don't know why. So here we can see the login produced by this application. And now I will stop that container. Sorry. Yeah. So now we are at the same application but using the structure login. Sorry, I used the another one, no? Yes. So here is the same information but structure. Okay, so it's easier to parse in the logging consolidation platforms this kind of information. It's harder for humans, but it's easier for integration. Okay, this is the way to use the structure data information. You should emit the message, and in data you put any information that you consider that it's relevant. So later, the platforms can query by specific fields. So here we can say, I want to see all the logs for this trace ID and filter them. Okay, another aspect that every smalltalk has. When everything fails, we need somehow to know what happens. So there is the trace in infrastructure. Trace can be generated as textual as usual, or in Pharo and VA, there is the option to serialize the stack. So later we can recover that and open in a development image to see what happened in our server. The debug mode serves to development, so when the application is starting in debug mode, Launchpad will not install a global error handler. By default, Launchpad applications, during the startup, will set up an error handler that if an exception is unhandled, and nobody handled that, they will enter this mode and dump the stack and later gracefully shut down the application. Okay, inline help, I will skim briefly because we already see it. It can use in the command line with Launchpad explain, or we can use it inside the image with inspectors. And finally, let me talk a bit about the Docker support. Launchpad provides a base Docker image, so you can start your own project, and this image bakes all the Launchpad scripts. And two other things. One is configure a health check. Docker has the option that every certain time it will try to do something with your application to see if it's alive. So you can configure that it's not responding, you can kill the container and start a new one. This is called a health check. Launchpad automatically does that. And also set up signal traps for SIG-term, for the Linux signal for SIG-term. So when the container is stopped, the applications have the option to shut down gracefully. So these traps are handled, and the image sends the stop message to the application, so you can stop and do any cleanup that you need to do. So here, if we saw the running containers, sorry. This one, that is the demo, was running for 3 minutes, and it said the status is healthy. This is the health check that is performing. If the image stops responding, it will become unhealthy, and we can configure that to kill the container and start a new one. And that's all. Oh, sorry. If you have any questions, I'm all here, I'm all yours. You can send me an email, find me in GitHub, and Launchpad is available in GitHub.
Questions? Yes. You talk about the health check that Launchpad does. Is that a replacement of the health check that Docker does, or is just something that actually is what Docker will query?
It configures the Docker health check to perform some specific thing.
So that health check is specific for Docker.
You can override it in your Docker file if you want to do something different, but if you do nothing, by default the image is running a local TCP server. So it will just connect to that locally and try to send some ping to see if it's alive.
Okay, thank you.
Maybe I missed it, but what Launchpad is a library?
It's a library. It's loaded inside the image.
Okay, you load it.
You need to load it and add it as a prerequisite.
Okay.
There are a few bits outside the image. There are some bash scripts.
Okay, and when you make the image for deploy, it provides you with all these.
Yeah, you have to subclass Launchpad application and do whatever you do in start.
Great. Okay.
But the other things are free.
Thank you.
Okay, thank you very much, Gabriel.